Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good day to everyone. In this video, I would like to discuss about numerical solution of second order ODEs with finite difference method. Here is the objective of this topic, where at the end I want everybody must know how to solve boundary value problem using finite difference method. Okay, now let's start for the introduction. The shooting technique for boundary value problem can present a problem of instability. The most common alternative to the shooting method is a finite difference approach. This method has better stability characteristic than a shooting method, but it requires more computation to obtain a specific accuracy. So here, these are the general form for second order ODE with boundary value problem. So from here, we can see we have y double prime plus pxy prime plus qxy equal to rx. Or we can write as d square y dx square plus p in term of x for dy dx plus q in term of xy equal to r with in term of x. Okay, and we have two condition. Okay, the first one, ya is equal to alpha, and the second one is yb is equal to beta, where the interval AB is divided into n sub-interval with a step size delta x. So this is the illustration. So we have a number line. We start from x not equal to a. This is from our condition here. And we end with xn equal to b. So this is the condition for here. Okay, so and then we divide from A to B with several interval with step size delta x. For finite difference method, boundary values y0 and yn are known. The approximate values for yi start from I equal to 1 until n minus 1 is computed. In finite difference method, a general form of second order ODE at the interior mesh points x equal to xi for I equal to 1, 2 until n minus 1. So this is the general form, okay? Y double prime plus pxy prime plus qxy equal to rx. Or we can write as y double prime I plus piy prime I plus qiyi equal to ri. It's very important for you to identify what is your p, what is your q, and what is your r. Then, by using central different formulas for first and second derivative, so these are the formulas, we substitute into our general form as shown before. So our equation will have in this form. After that, we multiplying both sides of the equation and with some algebraic simplification. So we have this equation. And we rearrange the equation. So finally, we have this formula. Okay, and we will start from I equal to 1 until n minus 1. Applying finite difference formula for each interior nodes leads to set of simultaneous algebraic equations. Then, after we have several simultaneous algebraic equations, we transform the equation into a matrix form, where the matrix form is in form of tridiagonal system. Okay, so this is the matrix. Why we call it as tridiagonal system? Because we only have value for diagonal element, where the rest is 0, where di, ei, and ci for I is equal to 1 until n minus 1 the coefficient of y1 until yn minus 1. Then, after we have a matrix where the matrix is in tridiagonal system, we need to solve the matrix. Actually, we can solve the matrix in any method that you already learned before, such as method from chapter 3. We have Gauss elimination with partial pivoting, or we can solve by using LU, or we can solve by using iterative methods. But in this topic, I want to solve by using Thomas algorithm, where these are the formula for Thomas algorithm. Here are the steps how to solve for finite different methods. The first one, make sure you write your equation into our general form. What is our general forms? Our general form y double prime plus p x y prime plus q x y equal to rx. Second step, please identify what is your p, q, and r. Where p, q, and r you can get from our general form. Next, step number 3, we compute the size delta x is equal to xn minus x naught over n by performing the discretization process. We substitute our p, q, r, and delta x into our equation. Next, we use the discretization output in step number 3 to write yi at each xi. For step number 5, we transform the system of linear equation in tridiagonal system. And lastly, we solve the tridiagonal system by using Thomas algorithm, or you can solve by using any method that you know. Okay, for better understanding, let's try one example. Use the finite difference method to approximate the solution of the boundary value problem y double prime minus 2y equal to 0. And the conditions given to us when x0, y equal to 1.2, when x1, y equal to 0.9, and our step size is 0.25. Okay, firstly, let's write the general form of our equation. So the general form y double prime plus p in term of xy prime plus q in term of xy equal to rx. And we compare with our equation. So this is our problem. Y double prime in term of x minus 2y, x equal to 0. And we already know that our problem already in our general form. So from here, we can directly identify what is our P, Q, and also R. Okay, our P is equal to 0. Our Q is equal to minus 2, while our R is equal to 0. Then, since given to us our step size, we need to calculate our n. We know our delta x is equal to xn minus x naught, xn minus x naught divided by n. So n is equal to xn minus x naught divided by delta x, where xn is equal to 1, x naught is equal to 0, divided by delta x. Delta x is equal to 0.25. So we have our n is equal to 4. So from here, when we sketch our number line, okay, so this is our number line. So we start with x naught equal to 0. And the increment is 0.25. So we have x1 is equal to 0.25. x2 is equal to 0.5. x3 is equal to 0.75. And lastly, we have x4 is equal to 1. And from the condition given, when x0, our y is equal to 1.2. And when x is equal to 1, our y is equal to 0.9. So we are going to find the value for y1 here, y2, and also y3. Okay, now let's substitute all the information we have into this formula. We have delta x, we have our p, we have our q, we have our r. Substitute everything, and this is the equation, and we simplify the equation. We will have yi minus 1 minus 2.125yi plus yi plus 1 is equal to 0 for I start from for where I is equal to 1, 2, and 3. Why I is equal to 1, 2, and 3? Because based on our number line. Okay, I write back the equation that we have before. We have yi minus 1 minus 2.125yi plus yi plus 1 is equal to 0, where our I will start from 1, 2, and 3. Okay, so let's start substitute I. Okay, we start with I equal to 1. From here, I will have y0 minus 2.125y1 plus y2 equal to 0. And we already have the value for y0. Y0 is equal to 1.2 minus 2.125y1 plus y2 equal to 0. And we rearrange the equation, so we will have minus 2.125y1 plus y2 is equal to minus 1.2. So this will be our first equation. Okay, we continue with I equal to 2. Okay, substitute into this equation. So we have y1 minus 2.125y2 plus y3 is equal to 0. So this will be our second equation. And when I equal to 3, I will have y2 minus 2.125y3 plus y4 equal to 0. And we already have the value for y4. So y2 minus 2.125y3 plus y4 is equal to 0.9 equal to 0. And we rearrange the equation, we will have y2 minus 2.125y3 is equal to 0.9, negative 0.9. So this will be our equation number 3. Okay, from these three equations, we can transform the three equations into a matrix form, where our matrix will be in a tridiagonal system. Okay, let's start to transform. Okay, so we have negative 2.125y1 plus 1y2 and y3 is equal to 0. How about the second equation? We have y1 equal to 1, y2 is equal to minus 2.125, and y3 is equal to 1. And for the last equation, we have y1 equal to 0, y2 is equal to 1, and y3 is equal to minus 2.125. Okay, this is for y1, y2, y3. So equal to negative 1.2, 0, and also negative 0.9. We can see here our matrix is in a tridiagonal system. Okay, so from the matrix, we can identify what is our B, C, D, and E. B is equal to, so this is matrix B. Okay, we have B1 is equal to negative 1.2, B2 is equal to 0, and B3 is equal to negative 0.9. And then C. C is this one. Okay, so C, this one, it starts from a row number 2. That means C1, we don't have any value. C2, we have 1. C3, we have 1 also. Then D. D is a diagonal element here. So we have D1 is equal to minus 2.125. D2 is equal to minus 2.125, and D3 also is equal to minus 2.125. And lastly, what is our E? Okay, E is this last one where it starts from a row number 1. That means we have value for E1, 1. We have value for E2 also 1, but we don't have value for E3 because for row number 3, we don't have value for E. Okay, for the last step, let's solve the equation with a Thomas algorithm. Okay, Thomas algorithm. So this is the formula for Thomas algorithm. Okay, for easy presentation, okay, let's construct a table. So this is the table. So we have first column for I, and since our I is equal to 1 until 3, so we have column for 1, column for 2, column for 3. For the first one, let's substitute all the value we have B, C, D, and E. Okay, this value we already last in the previously. And then let's start with how to calculate alpha I and beta I. Okay, so for I equal to 1, that means alpha 1. So the formula alpha 1 is equal to D1. So alpha 1 is equal to D1. So D1 is equal to minus 2.125. Then you cannot get alpha 2 and alpha 3. After you have alpha 1, you need to calculate your beta 1. So what is the formula for beta 1? So this is the formula. Beta 1 is equal to E1 over alpha 1. So let's check what is our E1. E1 is equal to 1 and alpha 1 is equal to minus 2.125. So the value we have is minus 0.4706. Then after you have beta 1, okay, start calculation for alpha 2. Okay, it must be alternate. Start from alpha 1, beta 1, alpha 2, beta 2, alpha 3, beta 3. Okay, for alpha 2, so this is the formula. Alpha 2 is equal to D2 minus C2 beta 1. Okay, so identify what is our D2. D2 is minus 2.125. What is our C2? C2 is equal to 1. What is our beta 1? We already calculate our beta 1. Our beta 1 is equal to minus 0.4706. Just use your calculator, so you will have this value. Minus 1.6544. Then calculate your beta 2 by using this formula again. And lastly, calculate your alpha 3 by using this formula. Okay, why for beta 3 we don't have any value? Okay, let's check. Beta 3 is equal to E3 over alpha 3. We have value for alpha 3, but for E3 we don't have any value. That's why beta 3 no value here. Okay, now after we have alpha and beta, so now it's time to calculate our Wi. So this is the formula that we will use for Wi. So we start with W1. W1, the formula is B1 over A1, alpha 1. So B1, what is our B1? Negative 1.2. What is our alpha 1? Alpha 1 minus 2.125. So we have here 0.5647. Okay, for W, you can directly calculate your I equal to 1 until 3. Okay, and then what is W2? Okay, we are going to use this formula. W2 is equal to B2 minus C2 W1 over alpha 2. So we just substitute everything. We have value for B2, 0. Minus C2. What is our C2? C2, 1. W1, we already calculate 0.5647. Divide by alpha 2. What is the value for alpha 2 here? Minus 1.6544. Then just using your calculator, so you get this value 0.3413. Okay, and then the same goes to how to calculate your W3 by using this formula. Okay, Lastly, we are going to calculate our yi. Okay, so this is our final answer. Okay, for yi, you are not going to calculate start from I equal to 1. You are going to calculate start from I equal to 3, then go to I equal to 1. It start from the last value until the first value. Okay, so this is the formula for y. We start with yn minus 1. So y3 minus 1 is equal to wn minus 1. Okay, so no, y3, y4 minus 1 is equal to our n equal to 4 and equal to w4 minus 1. That means y3 is equal to w3. So this is the value for w3. That means y3 is equal to 0.8163. Then how to calculate our y2? This formula. Y2 is equal to W2 minus beta 2 Y3. We already have the value for W2. This is W2, 0.3413. Beta 2 also we have negative 0.6044. And Y3, so this is our Y3, 0.1863. So you just use your calculator, so you will have the value for Y2. And lastly, calculate your y1 by using this formula also. So this is our final answer. I hope you can understand all the explanation. So thank you guys, all the best.